Let's get right into it. Number 5. Floating sky creatures. Picture a world where the ground is almost hidden under endless clouds. The air is thick, warm, and rich enough that huge living things could stay up there for most of their lives without ever landing. A place like that could be a gas giant moon, or even the upper atmosphere of a planet like Saturn. Scientists have also imagined life floating in the clouds of Venus because around 50 kilometers above the surface, conditions are much milder than down below. So what would these creatures actually look like? These things would be like living balloons, drifting islands of flesh, skin, and gas. Imagine giant bodies shaped like jellyfish, but flipped into the sky. Huge gas sacs would fill their upper bodies, keeping them afloat. Underneath would hang long curtains of tendrils, fins, or ribbon-like limbs that help them steer slowly through the clouds. Their skin might be pale silver, deep blue, or almost transparent, reflecting the light around them. In stormy weather, their bodies could flash with static sparks, like tiny bits of lightning crawling across the surface. Some might be small, only the size of a backpack, drifting in swarms like sky plankton. Others could be massive, hundreds of meters wide, moving so slowly that from far away they look like floating clouds. They could feed on tiny particles in the air, chemical droplets, or even sunlight. Their underside might be covered in fine hair-like filters that catch food as they drift. Others might trail sticky strands to trap smaller flyers. Here, the food chain would hang in the air. Tiny floaters feed on chemicals. Medium creatures eat the floaters. Huge predators glide through cloud canyons, swallowing whole schools of sky life in one slow pass. If intelligent life appeared in this world, smart floating beings could look like massive radial creatures with many dangling limbs, with a central body full of gas chambers and organs arranged in layers. They might communicate with color pulses through their skin, low booming sounds through thick air, or flashes of electricity during storms. Their tools would be lightweight, maybe woven from floating fibers or grown from living material. Their ships would not sail oceans. They would sail the sky itself, riding pressure currents the way ancient sailors used winds. Number 4. High-gravity creatures. Now, switch to a very different world. Imagine a planet much heavier than Earth, maybe a super-Earth with 2, 3, or even 5 times our gravity. A planet like Kepler-10b or HD 40307G. On a high-gravity world, everything gets pulled down harder. Life there would be compact, low, and built like a tank. The landscape on this planet might be wide, flat, and harsh. Mountains may not rise as high because their own weight makes them collapse more easily. Trees, if they exist, might be short and thick like giant stumps. The air near the surface could be dense, maybe even misty, pressing down with serious weight. Animals here would look squat and heavily built. Think thick legs, broad bodies, and a very low center of mass. Even fast creatures would move close to the ground. They might look something like a 6-legged armored crawler with muscles packed into every limb. Bones, shells, or inner support structures would need to be incredibly strong. Long necks, tall legs, and big wings would be rare because gravity punishes height. Predators might not chase for long distances. That costs too much energy under heavy gravity. Instead, they may ambush from cover using explosive, short bursts of power. Prey animals would likely be sturdy too. Maybe protected with low shell domes, thick hide, or bodies shaped like living wedges that hug the surface. Even the way they move could be strange to us. Walking upright on 2 legs might be uncommon. 4, 6, or 8 limbs would spread the weight better. Some creatures might almost flow over the ground like muscular pancakes, using waves of contraction instead of steps. Others could have body segments like giant pillbugs, with each section sharing the load. If intelligent life evolved here, it would probably be short, broad, and unbelievably dense, maybe around 1 meter tall, but with a barrel chest, thick limb joints, and hands with wide gripping pads instead of long fingers. Their buildings would also reflect gravity. Everything would be low, thick, and anchored. Their vehicles might roll on many wheels or crawl on many legs. Space travel would be hard for them because escaping a stronger planet means needing more energy. So, an intelligent species on a high-gravity world might become amazing engineers before they ever become astronauts. Number 3. Silicon-based life. Now let's go to a world where alien life does not use carbon the way life on Earth does. Carbon is perfect for making complicated molecules, which is why all known life depends on it. But in some real scientific speculation, silicon is always the big alternative. Silicon sits right under carbon on the periodic table, which means it behaves in some similar ways. A silicon-based world would likely be hotter, drier, and more rocky than Earth. Instead of forests and oceans, think of a landscape of black stone plains, mineral towers, toxic fog, and rivers that may carry strange chemical slurries instead of water. A planet with volcanic activity, little liquid water, and lots of silicates could be the kind of place where this becomes possible. Some exoplanets discovered in the last 2 decades, especially rocky super-Earths close to their stars, might have worlds similar to this. So what would these creatures look like? They probably would not be soft and wet like Earth animals. Silicon-based bodies might be hard, layered, crystal-like, or ceramic-looking. Imagine something between coral, insect armor, and carved stone. Their outer surface could be made of plates that slowly grow and repair themselves. Their muscles might be bundles of mineral fibers that flex when charged with heat or chemical energy. Instead of blood, maybe they move hot reactive fluids through tiny channels. Instead of skin, maybe they have a gritty shell with patterns like cooled lava. A small silicon creature might look like a many-legged shard clicking across hot rock on needle limbs. Larger ones could resemble moving boulders with glowing cracks between body plates. Some may grow in place for years, like mineral reefs, then break free and crawl away when mature. Others might use crystal growth as part of reproduction, slowly building offspring from seed-like cores. Their senses could also be wild. On a silicon world, life might sense heat patterns, vibrations in rock, electric charges, or chemical gradients in the soil. A predator could see footsteps from kilometers away by reading tremors through the ground. And if intelligent silicon-based life appeared, it might look almost artificial to us, a thinking being made from layered mineral plates, branching crystal organs, and glowing internal channels could seem more like a rock than an animal. But it would still be alive. It may think slowly if its chemistry runs at a lower speed, or surprisingly fast if it lives in extreme heat. Its cities might not be built the way ours are built. They might be grown. Mineral towers, bridges, and chambers could be formed by controlled crystal growth over decades. Their writing might be etched, fused, or encoded into crystal patterns. Number 2. Ammonia ocean life. Now imagine a planet or moon far colder than Earth. So cold that water is frozen like rock, but ammonia can stay liquid, especially when mixed with water. In our own solar system, moons like Titan have made scientists think hard about chemical life in freezing conditions. Titan has lakes and seas, though they are made of methane and ethane. On a colder exoplanet, vast ammonia-rich seas are possible. This world would be dim, cold, and strange. The sky might glow orange, gray, or dark blue through a thick atmosphere. Sunlight would be weak. The seas could look dark, oily, and still, with floating ice plates made of water, ammonia, compounds, or other frozen chemicals. The shoreline might be covered in brittle frost, chemical snow, and slow-moving fog. Life in ammonia oceans would have to work at low temperatures, which means everything might happen more slowly than on Earth. Creatures might drift, pulse, or crawl in slow motion. Their bodies could be flexible in the cold because their chemistry is built for it. But to us, they might look rubbery, translucent, or waxy. Small animals might resemble long, ribbon-shaped swimmers, moving with soft waves through the dark liquid. Others could look like pale armored crabs with wide paddles. Some might use chemical glows, not because it looks pretty, but because light signals travel well in dark seas. Imagine a deep ammonia predator with a body like a flattened squid, huge reflective eyes, and lines of blue-green glow running down its sides. Its mouth might not even be a mouth like ours. It could absorb nutrients through folded feeding surfaces or inject digestive chemicals into prey. Because the world is so cold, giant warm-blooded style creatures are less likely, but large, slow-moving life is still possible. There could be whale-sized drifters with antifreeze-like fluids in their tissues, cruising under sheets of floating ice and feeding on dense swarms of microbial life near chemical vents. If intelligent life evolved in ammonia seas, it might be fully aquatic. An intelligent ocean species might have a body like a many-armed cephalopod, but broader and lower, with sensory frills all around the head and skin that shifts patterns to communicate. Instead of spoken language, it might use color waves, chemical bursts, pulses in the liquid, or pressure clicks. Their science would begin with currents, chemistry, and patterns in ice. Their first computers might not be machines at all, but living chemical networks or carefully shaped crystal arrays near warm vents. Number 1. Plasma life. And now the weirdest one of all. Creatures made from plasma. Plasma is often called the fourth state of matter. It is what you get when gas is energized so much that electrons break loose from atoms. Stars are made of plasma. So the question is insane, but irresistible. Could life exist inside something like that? If it could, the world would barely look like a world by our standards. Maybe we are talking about the upper atmosphere of a gas giant blasted by magnetic storms. Maybe the corona of a star in some calmer region. Maybe huge magnetic fields trap charged particles in stable patterns. In the 2000s and 2010s, a few scientists played with the idea that under some conditions, charged dust and plasma can self-organize into structures that behave a little bit like living systems. That is not proof of plasma aliens, but it is enough to make the idea worth imagining. A plasma creature would not have a face, skin, bones, or organs the way we know them. It might look like a glowing knot of branching light held together by magnetic fields. Its body could shift constantly, stretching into loops, collapsing into spheres, then flaring outward like a living storm. Colors could ripple through it depending on temperature, charge, and composition. Blue edges, white-hot cores, red streamers, violet sparks. Instead of crawling or swimming, it would ride magnetic currents. Instead of eating solid matter, it could absorb energy directly from radiation, charged particles, or electrical fields. Small plasma organisms might flicker like hovering sparks, living for seconds or minutes. Larger ones could be storm-sized patterns that remain stable for days, years, or longer if the environment keeps feeding them. Reproduction could happen when one stable energy pattern splits into two self-sustaining vortices. An intelligent plasma being might not have a fixed body at all. It could be more like a living process than a creature. Its memory may be stored in field patterns. Its thoughts may move at the speed of electrical change, far faster than nerve signals in our brains. Communication could happen through flashes, radio bursts, or direct interaction between magnetic fields. A civilization of plasma beings would not build houses out of stone. It might create stable electromagnetic structures in the atmosphere of a giant planet, shaping storms the way we shape clay. To us, it would look like weather. To them, it could be architecture, writing, or even art. Life might not always look like something you can hold, hunt, or even touch. It might drift in the clouds, crawl under crushing gravity, grow from minerals, swim in freezing ammonia seas, or shine inside a storm like living fire. And if even one of those possibilities turns out to be real, then alien life will be far stranger than the usual big-headed green guy people have been drawing for decades. That's it for now. Subscribe for more.